Yeah, as you see, my name is Marco Rosa. I'm security researcher at SAP, based in south of France. And I'm going to present part of the job I do almost every day in my professional life. First of all, so after discussing with some of you yesterday, well, I was not sure anymore I chose the right wording in my title, because yes, we have to protect our coded credentials in public source code, but in the end, I think that the right way to tell it is that we have to protect the public source code from our coded credentials. But yeah, anyway, the agenda will not change. So before we start, did any of you ever leak credentials in, like on GitHub, for example, a password, API key? Any of you? Okay, so might be also useful for you, but you are not the only one, clearly. So we can say that everything kind of originated in 2016. So in 2016, Uber suffered from a very big and severe data leak where personal data of their customers, as well as their drivers, were exposed. So of course, Uber had an interest in understanding why this happened. And they made, of course, a kind of internal investigation. And in the end, they find the reason in one of their employees who leaked professional credentials, so username and password, for their internal services. So as simple as this, kind of trivial use case, but the consequence was disruptive. Of course, this was 2016, so 6 years ago. So we may expect that these kind of things don't happen anymore. But yeah, in the end, they do. So they still do 6 years later. The same attack scenario, the same consequences still there, even if we are aware since a very long time now that we need to protect our credentials, and most of all, be very attentive when we use them in, and when we code them in a source code. To bring some numbers into the conversation, there is a very nice report from Gitguardian. So Gitguardian is a startup providing some security tools. And what they did was basically they cloned all the public repositories from GitHub since 2017 up to today. And they used their security tools to scan what they found. And this is very impressive because only in 2020, as you can see here, they detected 2 million secrets, only in 1 year. And another thing we may all think is that, okay, you know, this is going to be a kind of decreasing trend, but in the end, it's not. On the contrary, it's increasing. So they said that compared to the previous year, the number of hard-coded secrets increased of 20%. We also have an interest in trying to understand where these secrets are leaked so that we can try to find a remediation. And, well, only 15% get found in repositories owned by organizations. This means that, of course, 85% are due to developers. So if we don't act as developers, it will be very hard to solve this issue if we will ever solve this issue. So on our case, we started wondering why this happens. And we tried to, or at least we made an estimation based on our observation of why this is happening. Why do people leak their credentials? Why do they hardcode their username and passwords, and then they publish this confidential information on github.com, visible to everybody? Okay, obvious answer is that best practices are not followed. Okay, that's pretty obvious. So we are all aware that, okay, we should never hardcode credentials in source code. We even have a lot of secure alternatives today, so like the usage of secure vaults, the usage of environment variables, even GitHub secrets, so without even knowing how to write code, you can securely insert your secrets in the settings of your repositories on GitHub. And that will be stored securely, and you can use them as in a secure way. For example, with CI/CD, they're very handy. But nevertheless, even if these countermeasures are quite easy, they are not followed, and people just hardcode credentials. There is another, so this was one reason. There is another reason, that is secrets get published in maybe private or hidden repositories, and then after some time these repositories become public for several years, for several reasons. So might be by mistake, might be because people do whatever in private repositories pretending they are private, so not visible. And then these repositories even get leaked, like it was the case of Twitch, Samsung, NVIDIA. So all these companies, they had their source code, internal source code, leaked by someone, some attackers. So some attackers gained access to their internal GitHub or GitLab, and then they just published the source code and let the internet inspect them. Another interesting cases are integrators and partners. Like this is more likely to happen with big companies. So big companies have, of course, their product lifecycle management, a lot of security tools that they have to use, security processes, but then they decide to outsource part of the development to a third party, and this third party maybe doesn't follow the same security processes. And finally, rare but existing, the intentional leaks, like someone trying to, I don't know, for some revenge, or maybe because as a consequence of bribery. So as an example, I may mention that there are hacking teams that are trying to contact employees of big companies, offering even a payment in Bitcoin in order to have some interesting credentials that they can expose. And if you, as a developer, accidentally leak your professional credentials on github.com, it's very hard to prove that it was an act of corruption. Yeah, so after trying to find the reasons, if there are reasons to do so, what are the remediation steps? So we can acknowledge, or well, the very first step, not in the slide, is acknowledging the problem. So if you get contacted by someone that tells you that you leaked up your Gmail password, don't blame him, but acknowledge the problem. That's kind of obvious to say, but not that obvious to happen. Then the next step should be to rotate the credentials. So don't pretend no one saw your password, just rotate it, and rotate it in a meaningful way. So if your password was Juventus1, don't choose Juventus2, because it's prone to be attacked with some stuffing attack. And then you have to clean up. So acknowledge, rotate credentials, clean up the mess you did. And also for this action, there is a do's and a don'ts. So the don't is don't push a delete password commit. So almost every 6 months, it becomes kind of a trend on Hacker News that someone posts, have you ever tried to find the delete password commit messages on GitHub? And then people have fun finding a lot of passwords deleted like this, because in the end, you just push another commit where you delete something, but all the credentials are still visible in the history of the repository. The right way to do it is to rewrite the history of the repository. It's more difficult, of course. It takes maybe more time, but that's the right way to do it. So use a git filter tree. Don't use another git commit and git push. And maybe less known, but it is also the main topic of the talk, you may have an interest in setting up code secret scanners. So if you already work in a company, you may have faced at some point some vulnerability scanners, like the famous one, White Source, Fortify, Black Duck. They're all great tools, but their target are vulnerabilities in source code. So you have to use a code secret scanner to find the secrets, because that's what they target. But of course, we still have 10 minutes for this talk, so it's not that easy, because you also need to choose the right secret scanner, because there are a lot out there, and yeah, not each of them will find every credential that you might need. So first of all, what is a code secret scanner? Because of course I made the parallelism with traditional vulnerability scanners, but it's kind of self-explanatory. So it's a scanner that targets your source code in order to find secrets. And there are two ways to do so. So either the scanner is based on entropy, so it will find strings that have a high entropy. So maybe very long and confused strings. And this works great with passwords that are automatically generated, like the ones that you may generate with the LastPass, and with tokens. So if you have, API keys for Amazon, for Google, for any provider, yeah, their entropy usually is very high, so you can find them with an entropy scanner. But they cannot detect simple passwords, which is the case for most of the leaks. On the other hand, we have secret scanners based on regular expressions. So these kind of scanners can find tokens and passwords or any information you want based on the structure itself of what you want to find. As an example, if you use the AWS, you will have a key from Amazon that starts with AKIA, so that's the prefix, and then it's followed by 16 random characters, alphanumerical, if I remember correctly. So you can write a rule to match these kind of strings in your source code. But when coming to password or unstructured tokens, that's very hard, because the only way you have to find these pieces of information is basically you can only match something like password equal or PWD equal. So something in your line of code that may refer to a password or to a secret. But of course, as you may understand, yeah, that's prone to cause a very high number of false positives. So you will literally be flooded by the false positive. You will not lose passwords because the recall is high. You will not have false negative if you just match password and you get all the lines of code matching password. But the problem is that you will have so many that reviewing them is almost impossible. But on the other hand, with the entropy scanners, you will lose a lot of secrets because you cannot detect anything simple. So, yeah, we have a problem with these false positives because they kind of prevent the usage of secret scanners. So the kind of solution that we try to propose in our team, which is the threat intelligence in security research at SAP, we implemented, yet another secret scanner because there are many out there. So there is Gitguardian, like the one that I mentioned before. There is even the secret scanner by GitHub itself. So if you have a license for GitHub Advanced Security, you can activate their secret scanner. It's great, and user experience is wonderful. You have even open source ones, like Git Secrets, like TruffleHog. There is one from Samsung that is open source as well. So you have a very wide choice. But yeah, the problem is that they don't target passwords. So we tried almost each of them. They target structured tokens, but when coming to passwords, they don't have kind of solution that goes beyond the usage of regular expression and then maybe entropy to reduce the spam. But that way, it's like using an entropy scanner. So the result that we try to give is this code scanner, which is open source. It's a secret scanner based on regular expressions, as almost most of the other ones. But the key differentiator that we try to propose is that we can find passwords with a low false positive rate. And we do so by using the regular expression scanner, but then apply machine learning models to distinguish between secure code snippets versus snippets that might contain a leak for your passwords. As I said, it's open source. It's available on GitHub. It's available You can download it from PyT as well. You are more than welcome to contribute. Since we heard already 2 or 3 talks today, like about the big companies exploiting open source, but if you don't want to contribute for free, you're free to apply to our open positions, and if you're a student, also to our internship positions. We have many, so just apply or send me an email. In order to prevent passwords from being leaked, because of course, if you scan a project, you find a password, the password has already been leaked. So it has already been made public. So in order to prevent this, we also have a pre-commit hook available so that you can block your credentials from going public at commit time. So the process is quite simple. So we have our repository, we apply a regular expression scanner, and we may have a set of discoveries that are supposedly containing some secrets. Then we apply these machine learning models. We have 2. So the first one that we call the path model that classifies these discoveries based on their path. So we observe that test files as well as documentation, tutorial, they usually don't contain credentials that then are used in production. So it's reasonable to think that those files, if detected, will be leading to false positives. And then we have a second machine learning model that is this password model that classifies, it's based on a natural language processing, and it classifies code snippets, whether like leaking a password or not. So yeah, we try to make it very simple to use the tool. We propose it to our colleagues internally at SAP. We received a lot of suggestions. So the first step is that, okay, of course, you install Credential Digger. We have 2 different clients that we support because we need to store credentials somewhere and these code snippets somewhere, because we also offer a UI, so we need to show stuff and we need to keep this stuff somewhere. So we support SQLite, which is super simple, and we support Postgres. So this example is based on SQLite because SQLite is quite simple, and if you just want to test the project, probably you will start with SQLite. So you just instantiate your client, you add your regular expressions. You can add 1 by 1 every regular expression you want, or you can just write like a configuration file and then add all these credentials from the file. Sorry, you add all these regular expressions from the file to the database. And then you can, of course, you can scan a repository. So there is this wonderful scan function. As you may understand, we don't have a lot of fantasy, so we try to keep the names very simple. You just decide what repository, what model to apply, and this similarity feature. So what is the similarity feature? The similarity feature is a kind of feature based on the experience that we had with our test users, because we noticed that even after decreasing the false positives using machine learning, still people complain that they saw too many false positives for some reason. Also because the notion of false positive itself is based on each user, each developer's perspective. So what is the similarity feature? In the end, what we do is we compute a kind of similarity score among our code snippets, so that when using the UI or when using the Python APIs from the library as well, you can flag multiple discoveries at the same time. So let's assume you have like a lot of code snippets in your results that are flagged as potential leaks, but these code snippets are maybe placeholders, and maybe there is, maybe 1 character that changes, like you have password equal variable password 1, password 2, password 3. Well, it's very pretending that someone has to go into each of them because they are almost all the same. So with this feature, we are able to understand when you flag a discovery if there are other code snippets very similar to that one, and we flag all of them in one time so that you can save up a lot of time. To draw the big picture, so we have this static code scanner, Credential Digger, which is open source. It's on GitHub, and of course, it's downloadable from everybody. Feel free also to use it, to integrate it wherever you want. I mean, the license we chose is Apache Tools, so it's very permissive. We have the machine learning model, the model, which is on Hugging Face, again, open source, and again, very permissive license, which is MIT. But we also have another tool that we use internally, which is this real-time monitor. So we do what also other people do, which is we have this monitor to kind of read real-time every commit, every public commit on GitHub. And what we do is we try to learn whether the commit contains some information that is important for us or not. So in our case, we are a cloud company. We have a lot of services, internal or external, that we sell and we may not sell. And of course, we have an interest in protecting them. So what we do is we check the public commits. We try to learn whether they contain something that for us shouldn't be public. And then to reduce the spam in case of passwords, we use the same machine learning model of Credential Digger, which is this password model. Great surprise for us was that we did zero advertising of our models and our tool, because anyway, it's not a product that we sell. It's available, it's open source. And even though we did zero marketing, I think, and even though the model is out there since, I think, October, well, at some point we got a lot of traction. So I didn't change the HTML of Hugging Face, so these numbers are real. And it was almost unexpected also for us. It's not like this anymore. I think I checked this morning, we had 10,000 downloads in the last month, which is still great. So I don't complain at all. But it means that people need some solution like this. So at least I hope we are helping them by with protecting their credentials. So to conclude, we still see hard-coded credentials, even if you saw that the Uber case was 6 years ago, and things have got worse and worse instead of improving. We also have easy remediation steps, like rotating the credentials and rewriting the history, but apparently they're not very followed. So on our side, what we tried to do was to propose a secret scanner that may target these passwords and may really help people protecting the information they are supposed to protect. Of course, I advertise Credential Digger because it's the tool that I maintain. But if you don't like Credential Digger and you like the one from GitHub or you like the one from Gitguardian, feel free to use them and integrate them in your DevOps chain. So thank you.
Thank you so much for the talk. We have one question here. Do you know the scanner code tools called Bandit? If yes, which differences there are with the Credential Digger? Yeah.
I think I already heard of that. Honestly, I don't remember. Because I've seen so many scanners lately that honestly, I don't remember what scanner Bandit is. I may assume that more or less is another code scanner that relies on regular expressions and then tries to reduce the false positives somehow. So I don't know the technique they use to reduce false positive, because that's the hardest part of the job. We try to provide our solutions with machine learning. I saw most of the others try to use entropy. This Bandit tool, I don't know. I honestly don't know.
So, okay. So now that you don't know, the second part of the question was your opinion, if it's a good choice.
Yeah, if it is a good choice, I think. Well, simple answer is any code scanner is a good choice if you don't use any so far. Yeah, but it's a tool that I don't know, so I really cannot express an opinion over it.
So I also want to ask the audience if there's someone with a question, since there's only one question. So
I would like to know what's your favorite method of securing credentials, like for example, environmental variables,
Yeah,
bolts.
so, okay. I mean, the one that maybe I use most is environment variables. But, you know, environment variables are good as long as you don't share like I don't want to say the account, but maybe you have technical accounts that you use in your team, and several people may have access to the same user space. In that case, environment variables are not good anymore. And in that case, another technique I really like is the usage of, but it's personal, I think, is using the GitHub secrets. So I think that for CI/CD, I mean, personally, I use that technique. I think it's very convenient.
Any other question? Okay. There seem to be no questions, so I think we'll stop there. So let's give him a round of applause. Thank you so much.
Yeah, thank you.